So hi everybody, and welcome to this webinar. I hope that everyone can hear me. Okay, you can hear me, great. So I'm Geoffrey Martin, I'm the marketing manager at the company Steel Project. Today I will be your host for this webinar, and Colin Maymon will also join me. He's the sales manager of the company. So I will pass it over to him a few times during this webinar for him to show you some practical examples with live demos inside our software. So today we are going to talk about Industry 4.0. It's a very important topic, more and more important in many companies. It's a vast topic that we are going to define together today. And the goal of this webinar will be to show you some practical examples when it's applied to our sector, which is steel fabrication. So before starting, one last thing, there is a Q&A section in your Zoom menu. So if you want to ask any question during the webinar, feel free to use this section, and we'll be happy to answer any question that you may have. So let's start with an introduction of our company. For those of you who don't know Steel Project, so we are a production management software editor for steel fabricators. So we offer a complete and digital management of your workshop on different for all the stations that you may have in your workshop, whether they are a manual station or CNC machine. And we are only in that sector. We are specialized in steel fabrication. We are the software division of the FICEP group. We've been inside FitShape since 2012, but we have worked together since the beginning of the company. So for those of you who don't know FICEP, which I don't think, but they are the number one worldwide CNC manufacturer for steel fabricators. Steel Project is present all over the world, as you can see on the map at the bottom. So we've got offices in France, where our HQ is located, but we also have some people working in Italy, Spain, the US, where we have a subsidiary there, also in Canada and in Brazil. We are also present through our customers worldwide. So you can see on the map where they are located, basically all over the world. And we have equipped more than 2,000 customers until now. And finally, we are also present thanks to the presence of FICEP all over the world. They've got 14 offices all over the world. The company was founded in 1994, so we celebrated the 25th anniversary of the company last year. We've got 42 people working in the company now. And finally, we are a Microsoft Partner Gold, which means that our developers are regularly tested by Microsoft, and it gives you an idea of the quality of our development. Now let's talk about our solution. So we market a software that we call Steel Project PLM. It's available on a computer for all the features, but some of them are also available on a mobile application. So you can use them on a smartphone or a tablet. So in this outline, you can see all the features that we offer. The first one being the import of the drawings from the detailing office. The second, the feasibility checks of all the drawings imported. So we compare what has to be done with what's available in your workshop to make sure that no errors are sent to the workshop. Then we can manage all the project from one interface and have access to all the information. Then we offer some section and plate nesting algorithm in order to optimize the use of steel. Then we offer a stock and purchasing module in order to produce with what you have available and to allow you to make some orders from your suppliers. And we also offer some interfaces with external software. It's very important for you to communicate between all your different software inside the company. So we've got some interfaces to make those exchanges easy for you. Then we offer the possibility to manage production. So before it begins at this stage, so the idea is to prepare production and to prepare all the workflows before production starts. Then the next step consists in actually launching production. So automatically first with the creation of the CNC programs for the CNC machines. And then we can launch production to the manual workstation with a mobile application that we provide for that purpose. Then we can also manage the shipping, also available on a mobile application. So directly on the shipping yards, you can prepare the shipping. And also we can follow up the erection site thanks to the mobile application. So from all those steps, we can collect some feedbacks, and those feedbacks will be used to track production live, to analyze the performances at different levels, at the level of the whole workshop or the one station or one operator, for example. And finally, all those information collected through the process will also be useful to manage traceability, the entire traceability, which is more and more important for you at the moment. So now let's talk about the topic of this webinar, which is Industry 4.0. So it's a phrase that was introduced for the first time in 2011, but we can say that it has been going on since the introduction of the internet on the 21st century. So it corresponds to the fourth industrial revolution in the history. So the first one was during the 19th century with the introduction of mechanical power thanks to steam. The second industrial revolution appeared in the beginning of the 20th century with the introduction of mass production thanks to standardization with Fordism, for example. They were the first one to introduce those production methods. The third industrial revolution was the introduction of the first machines run by programs. So the first, the appearance of automation, and that happened in the 70s. And finally, the fourth industrial revolution was the introduction of all the IT technologies available to the factories. So in other words, it's new ways of organizing production. So the convergence of the virtual world with the physical world. So in order to give you a more accurate definition of Industry 4, I'm going to explain 8 concepts that are very often used to describe Industry 4.0. So the first one, we already mentioned it, it's automation. So it's the fact of running a machine with a program. So all basically the CNC machines that you can have in your workshop, but it can be also some robots run by algorithm with more complex programs. Then the second concept is connection, which is the action of connecting 2 or more elements. So a clear example will be all the applications that you can have now on different devices, on your PC or your mobile, your smartphone or your tablet. So all these devices are connected together with one single application. The next topic is the Internet of Things, more commonly called IoT. So these are all the things connected to the internet and that act like sensors that send data automatically. So in everyday life, it can be a connected watch, for example, that will measure all your steps during the day and send the data back to an application. The next concept is intelligence and simulation, which is the ability to simulate production before it actually begins in order to anticipate any errors and optimize the flows of production. So a practical example would be some emulators that you may find in different software that will simulate the future tooling operations to anticipate any collisions, for example. Then the next concept is a big data, which is a phrase that we very often hear about. So the big data is the capacity to collect, to store, and analyze a huge amount of data. So, for example, when you are online visiting some website, there are some data that are being collected by the website that you are visiting, and this data can be used for marketing purposes after. But it's a very concrete example of big data. Then the next concept is system integration. So it's the ability for your different software to communicate with each other. The idea is to reach what we call the digital continuity, to make sure that the data is easily transferred from one system to the other, and that saves much time inputting data, for example. So one instance of that would be some ERP that you may connect with payroll software, for example. If you've got some production data regarding the presence of your employees in the ERP, you could have the possibility to connect that to a payroll software. Then the next concept is cloud computing, which is the capacity to store online instead of storing data on physical servers. A clear example in the everyday life is the possibility for you to store your personal pictures, for example, in the cloud instead of storing them in one computer. So it's a way for you to secure the data. In case something happens to your computer, the data is not lost. And finally, the last concept that can define Industry 4.0 is what we call corporate social responsibility. So it's the consideration by company of social, ethical, and environmental issues. So an example for that would be for a company that tried to enhance the working conditions for their employees, or maybe a company that communicate on their actions for the environment, for example. So now let's talk about Industry 4.0 and when it's applied to steel fabrication. So we are now going to show you some practical examples when it's applied to our sectors. Industry 4 is at the heart of our development strategy. So we always study what's being done on other industries, and we try to make some new features and apply them to our sectors. So now let's see some clear examples for you to see what it's like with our sector. So first example that we can give is about system integration. So the ability to exchange data with some external software. So on that slide, on the outline on the right, you can see where we are positioned in your processes inside your company. So our software is called CPROX PLM. PLM means, in our case, production lifecycle management. So there are three phrases that describe what we do. The first one is CAM, computer aid manufacturing. So that corresponds to the ability to prepare the elements before production and prepare all the machines before production. Then the second is nesting. So the ability to use some algorithm to optimize the use of raw material. And finally, MES, that means manufacturing execution system, and that corresponds to the ability to interact with the workshop live and to track what's happening in the workshop. So you can see in the outline that we've got some different possibility to exchange data with an ERP, a detailing software that you are using at the detailing office. We can also exchange data with some nesting software that you are already using. and we can also exchange data with MIS software that you may have, such as Tekla Power Fab, Strumis, ConstruSteel, for some of the software that you may have. And for all of them, we can exchange data either in a PNI format, which is a format that we have developed and that has become a standard in our industry to exchange data very easily. For example, with a nesting software, we could import some nesting that you have done in an external system. Or if you are managing your stock in an MIS, for example, because they are more focused on the administrative aspect of production. If you manage stock in them, we can import some stock information from them. And we also have developed some standard interfaces with some very important ERPs. And finally, in case we don't have an integration with one of your existing software, we can develop some specific integration. We've got some developers that may work on that. So now let's talk about the interfaces that we have with the detailing office. So when you are ready, when you are done making all the project inside the detailing software, we have the ability to export this data and import them inside our software. So we can import data coming from a Tekla structure, Advanced Steel, AutoCAD, BoCAD, SolidWorks. So basically all the software that you may find in your company. And we can import those data in different type of formats. It can be DSTV, DXF, DWG, step files, etc. And the idea is to get all the information thanks to those imports. So as you can see in the slide here, we can import data related to the profile distribution on one project, for example, in quantity or in weight. We can also have access to information such as the weight, the surface, the number of components of our assembly. And finally, we will import the geometry of the pieces and we will analyze it inside our software. So for example, if you import that data from AutoCAD, which is a 2D detailing software, we will be able to generate the 3D view of that of those pieces and use a 3D engine inside our software. On top of all the traditional files that you can import inside our software, we have developed some more advanced format that we call XML and IFC. Those are more advanced format because they are more rich in information, and you will have some more possibilities after to make some to improve your productivity. So let's talk about the XML first. The XML is the one that we have developed with a Tekla structure. It has some possibilities. The first one is all the information that we will import will contain all the structure of the project. So the information will be very detailed. So we will have the information related to the assemblies, for example, and inside our software, we'll have the possibility to visualize these assemblies in a 3D. We also import all the weld information that you have configured inside the detailing software. We will also have the possibility to import one file for one project, which is much more convenient than importing hundreds of files, DSTV files, for example, that can be lost during the process. And since we know the assembly information, we'll be able to make what we call the scribing, which is a technology that was created by FICEP, and that allows to mark the position of the pieces on the master parts and have this information on the welding station for the operator, and we'll be able to optimize those scribing lines. So now we'll pass the word to Colin. He will show you a practical example of an export from Tekla and what can be done with an XML file inside our software after that.
Okay, hello everybody. So as Geoffrey told you, my name is Colin. I'm the sales manager of a steel project company. I guess you can see my screen. Yeah, Geoffrey, you can confirm.
Yes.
Okay. So some of you knows me, and I know some of you. I saw in the list of a participant that some name that are well known. So thank you for being there. So yeah, well, I will just want to show an export from Tekla. We work closely with Tekla since years. We did develop this XML file since a long time. This XML file, you can find it here. It's a macro inside Tekla. It's very easy. You just have to click on the XML here and we will generate an XML file with every single information of this project inside. So it will be the project, of course, all the phases, all the assemblies, and all the components, plus all the markings, the scribing line, every single information in one unique format. So you need to know that this XML file, we did develop it since 12 years. Since, let's say 4 years, we've got also possibility to import IFC files from Tekla, but also from other software. The IFC, in fact, is a kind of our XML. So we were much in front with our time because we already developed that since 10 years. But you need to know that we can import those BIM models like XML or IFC. So XML is from Tekla and IFC is from Tekla and other detailing software. So it's quite easy because it's only 3 clicks in Tekla you need to do. Then you have to jump in Steel Project PLM. And you will import, well, or your IFC if it's an IFC, or the STV if it's the STV, the XF, whatever, or a Tekla XML, which is the case today. So I just have to click on Tekla XML. I need to browse in my computer, where is my model? It's here, and click on OK. When it's done, I will import it in Steel Project PLM quite quickly. I will change the name here for the webinar. I will call it webinar test, okay. And I will import it in PLM, Steel Project PLM. So once again, it's 3 clicks in Tekla. It's like 3 clicks in Steel Project. So it's quite convenient, quite easy. And once again, you've got every single information in one unique format. So it's very modern way to import. So it's nearly done. Here we are. I did imported it. So now I'm jumping in Project Manager, the module where we import all our project. And I will find my project here, webinar test, okay? So the project is divided in project, drawing or phases, assemblies. So I will be able to see every single assemblies in 3D, okay? So I've got this assembly here. I could take another one, whatever. When I've got an assembly, if I click on components, I will see all the components making this assembly. So plate of 8 plus an IPE, okay? So you see all the scribing line here in yellow are full line. You can see here, they are full line, okay. What is interesting in our software, we can customize the scribing line. So if I go back on my assembly, I can make a right click on my assembly, go in tool, adding scribing. So I can add some marking or take them off. I can add positioning marks or take them off. And I can customize my scribing line. So for now, they are full like that, but I can decide to make it partially like that, or even more partial. So here I've got only the corner. On a round, I've got only 4 points. On an eye, I've got those corner which will be scribed. So if I say OK, and I apply it on my assembly, you will see now, if I go on my component, that I've got a positioning marking here, okay? In order not to weld this part upside down, I've got this positioning marking here. And if I go on my masterpiece, I will see that all the scribing line has been customized, as we can see here, okay? Make a rotation. So I've got the beginning and the end. I've got the name of the piece plus the positioning mark here. So it helps you to earn a lot of time in the workshop to avoid mistakes, because a welder and in assembly, you cannot mistake, and it's not possible to make a mistake when you've got all these positioning marks. So I will give back the word to Geoffrey for the following of the webinar. Geoffrey.
Thank you, Colin. So this example shows you the advantages of exporting very rich information, and because it allows many more possibilities after that during production. And just to talk about the sanitary crisis that has been going on, these type of things are very important for you. Because for this example of the XML, when you are sending some pieces to an assembly station with all the information on the piece, you don't need to manage any paper. You don't need to make some trips inside the workshop. All the information are included for the welders to work straight. So it's an example of the advantage, especially during those times. Now, a final example of a system integration that we have is the for dealing that we've got with a Tekla structure. The idea is to track production directly inside the Tekla model. So we will see after that we can track production live inside SteelPro PLM with some color codes that are applied to workstations, and those color codes can be sent back to the Tekla model in order to track production directly inside the model. So as you can see on that example, the dark green are for the CNC cut machine. So you can see that all these parts went through the cutting machine. So now let's talk about intelligence and simulation, and the example of what we call the virtual workshop inside our software. So basically, you can configure all the machines and workstation that you have inside your workshop. For all of them, we will configure all the tooling operations that are available, and from that information, we will determine some workflows depending on the parameters of the PCs. You will allocate some piece to some machine and some others to other machines. You will be able also to change those workflows directly. So if you've got some machines that are two machines that are able to make the same operation, you can decide to allocate some group of PCs to another machine in order to avoid bottlenecks. Another interesting feature with that is the possibility to have some estimated production times. So we will have some formulas that we will calculate depending on the geometries of the PCs. And for each piece or group of PCs, we will determine some estimated times by workstation or by tooling operation. So the idea for that is to help you plan your production. Another example of intelligence in simulation are the nesting algorithm that we offer inside our software. So they are specifically designed for steel fabrication. We can manage some complex pieces and create the CNC data of the nesting that we have created. So I insist on that because it's not the traditional nesting that you will use for managing your stock and only to order some pieces from your supplier. It's not a basic nesting like that. It's a very complex algorithm that are specifically done for our sector. And for the plate nesting also, we will know the capabilities of the machine, and we'll be able to manage some nesting depending on the capabilities of the machine. If they are able to make some common cuts, for example, we'll be able to configure the sequences accordingly. So now I'm going to pass it over to Colin again, and he will show you some examples of plate and section nesting.
Okay, thanks, Geoffrey. Sharing my screen. Okay, so here I will go in a section called fabrication job. Fabrication job is where you prepare all the production you want to do. So I did prepare two production here, one for plate and one for beams and haunches. Okay, so I will start with beam and haunches. I've got a composition of pieces here. I will click on section nesting, which is our bar nesting module here. The software will open this module, showing me, well, all my pieces here. So we've got some haunches, as you can see here. We've got some beams, well, different type of products here. I will click on automatic here. and I've got a section nesting parameters here. So I can define how I want to make this nesting, if I want to leave a time for the algorithm to find solution, if I want to give a priority to the result, like limiting the scrap or limiting the number of bar. Well, there's loads of parameter here. I won't enter in detail. But if you click on OK, the software will automatically make this nesting the best way possible. As Geoffrey told you, we try to make an algorithm which is making intelligent nesting in order to save steel. So you can see here a bar. If I deploy it, I can see all my pieces in yellow inside, okay? If I zoom on it, I've got some, okay, color codes corresponding to scrap in red. So I can see the scrap, I can see the size of the blade, considered as a scrap. Okay, every single piece is inside. In orange, it's all what is scoping. And at the end of my bar, I've got a green part, which is a remnant. Remnant can be reintegrated in a stock for later usage. We can also nest haunches, as you can see here, in order to save steel. So let me take a great example here, for example, this one. Okay, so you can see that we nest those haunches the best way possible in order not to lose steel and to optimize really all the raw material you can have in stock. Okay, so that is for beams. Now I will jump in the plate nesting module. I'm just saving my nesting here. Okay, I will quit. So jumping back in my fabrication job section. So you can see that my haunch and beams webinar now is green. It was red before because red is not nested, green is nested. So now I will take my plates, which is not nested. I will click on plate nesting. It's exactly the same principle as the bar nesting. We will load all the pieces and we will make a nesting. We can make a nesting on multiple thickness. I mean, if you've got thickness of 8, 10, and 12, it will nest in different plates. All those pieces. You can mix different projects also. So here we can see that I've got two projects, one called 0451, one called test W. So whether in the bar nesting and in the plate nesting, you can mix different projects. It's multi-project nesting. Well, here I will save and I will click on automatic here. The same way, the software will make the best way possible the nesting. So there's multiple parameters. Once again, you can divide a plate in 2 or 3 zones in order to make a zone in priority. You can make common cuts, you can make bridges. There's really multiple parameters. The goal in this webinar is to give you an overview and not to enter in details too much. But of course, it's possible. The goal, once again, is to find the best result as possible and to save steel. So here, my plate is nested. Here, I've got one plate. I've got a second one here. Okay, I will save. And then going in my fabrication job, I will see that status is now green. Clicking right, I can send in production. Okay, so it's quite easy and convenient to use. I give back the word to Geoffrey. Geoffrey.
Yes, thank you, Colin. So now let's talk about another example of intelligence and simulation, which is the tooling technology management that we offer inside our software. So Colin show you a little bit of this feature with the parameter describing that you can parameter inside our software. So the idea is to have the possibility to adjust the pieces before sending them to production. So in case you want to change the diameter of all the drilling on one project, you will have the ability to make a right click and apply the change of one diameter to the whole project. It can be useful, for example, if you've got one tool broken inside the workshop and you don't want to stop production. You could also have the possibility to substitute one tooling operation. So, for example, if you want to replace all the drilling operation by punching, you can make that change very easily. Or finally, if you don't have a robot, but you need to make some pieces, we'll have to you will have the possibility to make some scribing on the location of those cuts, and then you will have the possibility to make them with a manual saw after that. Then we will have a check part tool. So the software will analyze all the geometry of the pieces in case there are any errors that were sent from the detailing office. And the software will also analyze if you have the possibility of making all the tooling operation inside the workshop. So at this stage, it will prevent you from sending any errors inside the workshop. And also, if you need to make any change or create new pieces, there is a drawing editor that you can use in Steel Products PLM. So it prevents you from asking the detailing office in case you have to create new parts. So it gives you flexibility. And finally, any change that you make can be stored inside the software with a revision management tool that allows to compare and create revision very easily, and it saves you much time. So now let's talk about automation, which is the historical know-how of the company. So the ability to convert the data that you get from the detailing office to CNC programs for the CNC machines. But not only we can make the programs for those, we can also program the workflows. So since we know the workflows for each piece inside our software, as I told you before, we will have the possibility to create the CNC data for that. So FiceSep, for example, they provide what they call the automatic conveyors to transfer the pieces from one station to the other. We will have we'll have the possibility to create those CNC data to make all the transfer automatically. And this is what we call intelligent steel fabrication, because the entire process is is done automatically that way. So now let's talk about connection, and let me introduce our first mobile application that we call the Workshop Assistant, and that consists in managing manual workstation digitally. So manual workstation can be a welding station, as you can see on the picture on the right, but it can be also an operator working on the shipping yard. It can be also a machine that is not equipped with a CNC. And you will have many different possibilities to manage those stations. So I will pass the word now again to Colin. He will show you what can be done with the mobile application. And it's also available on PC as well.
Okay, thanks, Geoffrey. So I'm taking back the end on and sharing my screen. Okay, so this workshop assistant, once again, is not dedicated to be in the office, but in the workshop or wherever you need it around the workshop. So it's available on computer, on Windows tablet, or Android smartphone. My example here will be on an Android smartphone. So you just have to click on the app. You have to sign in the morning, so you can scan a badge with your name. If you've got here, it's my name, Colin Maymon. You can scan it and enter in the system. You've got here a zone where you can declare that you're starting to work on an assembly station, for example. So in the morning, you declare you work in. At the end of the day, you log out to count the hour you've been in the company. You have a scanning mode, of course, in order to scan what is QR codes corresponding to assembly or to a job. When you click on it, it will pop up directly the good job you have to do. It will open it. You can make this manually also, clicking here, selecting the workstation you're working on. So here it's assembly, selecting a job manually. Okay, you can filter and say, okay, I will work today on a job called webinar beams, for example. Okay. When you apply the filter, it will open all the assembly you have to do for this job. Okay. So you can pick up an assembly, whatever, this one, for example. When you click on it, it will open you a screen where you can see your assembly in 3D. So on the mobile phone, on the computer, everywhere, you can see it in 3D. Okay, it's quite convenient for the welder, for the assembly site, where you can make rotation. You can see what it should look like when it should be finished. Okay, so that's quite convenient for the guys in the workshop. You can click here and see the detail of the assembly. Okay, plate of 8 plus master beam. You can have a counter here. So when you click on it, it will start a counter. You declare you start to work. So you see a counter starting here. You can declare some traceability for welding traceability, whatever kind of traceability you want to pop up, you can scan it. You can put some comments, okay, like if everything went okay on this assembly, you can put it, or if you had a problem, you can give it. You can make some pause, okay, declare a pause, lunch break, a pause, whatever. So when you declare it, the counter stop. When you come back from your pause, you start again, the counter start again. And then when you click on stop, you will declare the assembly as done, as assembled, okay? So it's coming back in PLM. You can also declare some operation. So if you're on assembly workstation, for example, you can declare an operation here. Like it can be a cleaning operation, a maintenance operation, whatever kind of operation. You click on the project here. You will select your project, Feature Open House, and then you will give a time. Okay, it took 2 hours of maintenance on this project, and you click OK. So declaring those operations help you to give back some cleaning time, some maintenance time related to a certain project, in order perhaps to charge your customer on all those ghost time that can be done in a workshop for a project. Okay. So I give back the end to Geoffrey for the rest of the webinar. Geoffrey.
Yes, thank you again, Colin. So let's continue on the connection aspect. Colin mentioned some scanning system that can be connected to our solutions. So the idea is to have the possibility to facilitate the input at any stage of the process. So those scanning systems can be for barcodes or QR codes, because they are more and more used. The idea is to facilitate the input. So first example, if you are on a CNC machine and you create the CNC program, we can create a barcode that the operator will scan directly at the workstation. So instead of choosing on the CNC and navigate on it, just by making the scan, it will launch the program. It will be also very useful for the operators with the workshop assistant. So instead of navigating inside the application, if they are wearing gloves, for example, they will have the possibility to scan the different pieces. We can create some labels for any piece. So the operator will be able to scan the identification of the piece. And also inside the application, we will generate some action barcodes. So instead of navigating, the action of clicking will be replaced by a barcode. So all the application can be used with only a scanning system, and it helps save much time inside in the workshop. Another example of connection is the ability to manage different sites from one location. So I told you about the virtual workshop before. There are different tabs that you can configure that corresponds to the different location that you may have, and everything can be done remotely. So sending programs or work orders to a different location and track production from there. It can be done remotely. So now let's talk about the Internet of Things with what we call the Workshop Supervisor, which is a module inside Steel Products PLM on which we will have all the machines configured. And the idea on that is to track all the machines and the manual station live. So for all of them, you will be able to see if they are running or if they are stopped, if there are any alarms or alerts occurring on the machine, what is the program or the work orders that is being processed, when was the last time we received feedback from that station, who is the operator in charge, and so on. So there are it's very important to have a quick overview of what's happening in the workshop instead of going actually there to see what's going on. And we have also implemented since last year a messaging system, which is very convenient to give some instructions. For example, you can do that remotely, so you don't have to use an external application for that. Everything is done on the software, and the idea also will be to record all this information for traceability purposes. So everything that is shared will be stored in the database. Another example of Internet of Things is the production feedback. So we mentioned a few times that during this webinar. It's very important. So these are all the feedback that we can collect at different stages of the process. So it can be done automatically on the CNC machine. We collect data automatically from them. It can be done with the mobile application workshop assistant or on its PC version. So it can be done on a welding station or painting station, but also from the shipping yard. And also, because now the application is available with the 4G data, not only with the Wi-Fi, the application can be used directly on the erection site. So the operator can track all the pieces that are being erected, and the information will be sent back to Steel Projects PLM. So with all this information collected, we will then have the possibility to manage them, and that gives me the opportunity to introduce big data. So the first possibility with those feedback will be the ability to track production live. So I told you before that we have a color code system inside Steel Projects PLM. So for each machine, we configure one color code, and this color code can be seen at different level of details. If you want to see at the level of the project, the phases, the assemblies, the secondary parts for very accurate information. But it can also be tracked with a fabrication job, nesting, lots, any type of details that you may want. Another possibility with all the feedbacks will be the possibility to analyze the performance of the workshop. So on that screen, I mentioned the second mobile application that we offer, and that allows to measure the performance of the FICEP machine. So this is available only with a FICEP machine. So basically, we will configure a time period that you want to analyze. And on that time period, you will have access to key performance indicators, such as the weight, the production times, the number of bars per hours, etc. So it's just an example of all the analysis that you can have inside our software. I don't have the time to go through all of them, and Colin will show you some more after that. But the idea is to analyze the performance at this stage. So it can be done once again at different levels, at the level of the whole workshop, at the level of one project, or at the level of one operator. You can know how one operator spends his time during a period of time. Then, with all the feedbacks collected, the final possibility will be to manage the entire traceability process. So there are two levels that can be analyzed. The first one is traceability of production. So basically, who did what and when and how. So it can be done automatically from the feedback from the CNC machine, but also manually from the manual workstations. And also the traceability of material. So once we receive the material from your suppliers, we'll create an identification that can be tracked during the whole process. So the cast number will be followed until the erection site. And not only material can be tracked, but also all the consumables. So at any stage, you can add any consumable information. As you can see on that picture, one operator scanning a welding wire that is going to use on one assembly, for example. And those information will be collected, and then we will have the possibility with all of them to edit some traceability reports. So Colin will show you. It's very easy. You just click on export and you will have a document with all the information, and you will be able to give that document to any persons involved in the project. It's very important for you, especially for some norms issue. For example, in Europe, there is the norm EN 1090 that is becoming more and more important. So this is very important for that purposes. So now I'm giving back the word to Colin for the last time for this webinar, and he will show you what can be done with all the feedback collected from the workshop.
Okay, thanks, Geoffrey. Back on my screen. So here I will jump in production manager module where I've got a project I already worked on in order to make some feedback. So it's here, it's this one, feature open house. Okay, so you can see some color codes corresponding to some operation. Light green, sent, dark green, tooled, red assembled, yellow quality control, and so on. So you can see these color codes at every level, at the level of the drawing, at the level of each assembly here, and at the level of each component of your project. So here you can track visually what has been done in your project. What is interesting here is that we've got an analysis tool, if I click right, which will open some different features. So here I will see what has been nested in my project, what is not in a fabrication job. So I see what has been nested out of my project, what is not nested yet, okay, in terms of weight, in terms of quantity. I will see here with percentage what has been sent, what has been tooled, what has been assembled, what has been controlled. I can see in terms of production, in terms of quantity, of weight, of time, what has been done, okay? I can see here clearly the time I spent in cleaning, maintenance for this project in terms of ghost time, as I was talking before. So in terms of quantity, but in terms of time. So we see that we've got 30 minutes of maintenance, 1 hour and 30 of cleaning in this project, okay? If I go on a nesting now, I will see for each nesting here, if I double click, I will have some information of time for every single operation. I've got a comparison time. So the focus time for this beam was 41 minutes. It took 41 minutes. That's perfect. But my example is perfect because I don't have machine connected. But you understand that we've got the forecasted time here, and the machine will give back the real time of production. So if you've got 1 hour and 41 minutes here, there's a problem because it took 1 hour more than it was supposed to. You've got all composition, all the alarms coming from the machine on this particular beam. If I go here on assembly, I've got quite an interesting tool showing me that all my assemblies are here. And here I've got some assembly ready to, I've got the color code telling me that this assembly is ready to assemble. So you see when it's green here, it's ready to assemble. Here we've got white because it's not completely tooled, so it's not ready to be assembled. So here we can see that it has been sent, tooled, 100% assembled, and quality control partially, okay? So that's quite interesting for you. If I go on parts here, that's also very interesting table, because you will see here very quickly, visually, what has been sent, but not tooled, not assembled, not controlled, not paint. What has been sent with the quantity here, okay? So here we can see that this piece has been sent, tooled, and assembled, not controlled, not painted. This piece has been fully produced, partially produced, 4 out of 7. So we've got a table which is visually very simple to understand and to see the advancements of each component or in your assembly, okay? I've got a tooling information here. So for each part, like this F19, I know it will go on the Gemini, then it will go on assembly, on quality control, and painting. If it's already produced, I will see it here. I will see the quantity, the time it took, and the date of production. If there's an operator, a tracking ID, I will see it here, okay? Here I can see an operator, which is me for assembly and quality control. Here I've got some tracking ID coming from the stock, okay? So those tracking ideas are coming from our stock module, or they can come from your ERP or whatever information we will input in the system. You will see all the operations. So once again, I made like a maintenance operation on my Gemini for 30 minutes, the date of today and yesterday, and the drill and saw cleaning for 1 hour and 30 minutes, okay? The workstations show you the workload of every station. So if we take the robot, for example, it's telling me that I've got 13 pieces left to be produced. So it's 2.11% of the global project to be finished. On the drill and saw, I've got 2 pieces left, 0.32% of the project to finish the project. I've got a Gantt graphic here showing me that the date is yesterday because I did make the production yesterday. From when you start to work, the drill and saw start to work at 8:30, stop at 4 o'clock. The cleaning time, here we can see the Gemini 32, when it started, when it stopped, and so on, okay? Assemble here. So you've got this Gantt graphic showing you what has been done and when. And finally, here you've got the stock traceability information. So we've got here 3 beams with unspecified tracking idea. So no tracking idea, no tracking information, no traceability information. But if I go on this one, I will see that with this tracking idea, I've got two beams produced with every single pieces inside. So I know which beams has been produced with this traceability idea. And then you will link to this traceability idea some traceability documentation, some, how do you call that? I don't remember the word, but anyway, all the traceability will be here with all what has been produced with it, okay? Once again, that can come from our stock, or that can come from your ERP. We can import that through a PNI format. What is interesting here, that you can create a traceability folder, okay? This traceability folder will regroup every information about this project of what has been done by whom, when, who was the operator on all the traceability figures. So I did create it. And now if I jump in my computer where I store it, I will go in SPPLM, traceability folder. So I did create it one today. I click on it. So here you can see all your traceability number. And if I click on the Excel file, it will open me an Excel file with a resume of all this information. So for this component, you know on which machine it did pass, what was the type of profile, the designation, when it has been produced, the traceability number, the quantity. For this component, we can see that it's been through the Gemini, the assembly, the quality control, the quantity, the date, who was the employee, and so on. So you've got really a summary of all your project that you can give to your customer in a zip file or on a USB key. It's very easy and convenient. And the software does it automatically for it. So once again, to answer the norm EN 1019 that we've got in Europe, that's really an answer to this norm. And I'm sure it can be useful for our customer outside Europe because you've got also norms in traceability requirement. Last thing I want to show you is the kind of report that can be made by FeedShape machine. So this kind of report is available only with FeedShape machine, okay? I insist on the fact that we can connect all kind of CNC machine produced in the world, not only FeedShape, but all kind of machines. But all what is feedback and all what is tracking what is going on the machine, the FeedShape machine are giving an automatic feedback automatically, transparently, which is not the case for the rest of the machine of the competitors. Okay, so this kind of report you've got in front of your eyes is really a specification of our FeedShape machines. So what can we see here? We've got the starting date, final date. So it's on 1 week between the 29th of January and the 2nd of February. In 2018. This example is coming from a real customer, which is in Germany. It's on a 603 DDV drill and saw. So what do we see here? The name of the operator, the type of profile, the length, when it started, when it finished, the time in between, and the efficiency of the machine on this bar. Okay, so for each bar on a 1 week time, you've got this report. Okay, so what is interesting us is the last page, because the last page is a summary of the week of production. What do we see? What do we see here? So between this time period, it was 104 hours. Out of those 104 hours, the machine was off 24 hours and was on 80 hours. Out of the 80 hours, the machine was feeding back something 73 hours. So what does it mean, feeding back something? It can be production. It can be in tool setup. It can be ready to start without starting. It can be stop with messages. So it was 73 hours giving a feedback of doing something, okay? And the real time of production was 57 hours out of the 73. So the real production time is cutting, drilling, punching, scrubbing, whatever operation with this real production, okay? So the difference between these 73 hours and 57 hours is here. So we lost 2 hours and 70 minutes in alarms, 18 minutes in standby, 2 hours and 50 minutes in tool setup, nearly 7 hours in ready to start. So with an operator not pressing the button. So here we've got a bottleneck, because you shouldn't lose 7 hours with the machine ready to start, not starting. 1 hour and 26 minutes ready, stop with the messages, and 2 hours and 47 minutes in raw material loading. So the efficiency of this machine out of this period was 71%, which is actually quite good. So this kind of report can be done daily, weekly, monthly, every two days, every half weeks. It's up to you. And once again, it's a specification of each machine to give such a complete feedback with such detailed information. So I think this is the end of the webinar for us. I thank you for being there. I will give the word to Geoffrey to give conclusion to this webinar. Geoffrey, the word is yours, and thanks everybody again for watching.
Thank you, Colin. So before making the conclusion, I will give you the opportunity to ask any question that you may have. In the meantime, I thank you for your participation to this webinar. We hope that it was very useful for you to understand what Industry 4.0 looks like for steel fabrication. So by the time we receive any questions, maybe you can see on the screen our contact details. So you can visit our website for more information, and there is also a form in the contact section if you want if you want to contact us. And there is also an email address that you can use. So you can contact us for a more detailed demo, because even if it took some more time than expected, we didn't have the time to cover everything. So you can get in touch with us for a more complete demo. So I can see that there are some questions in the chat. No question, just thank you. Okay, Thomas, I will give you an answer after the webinar regarding the IFC files. I will write you complete answers.
Okay, if there's no more question, let's say goodbye to everybody, and hope to see you soon somewhere in your country, or in Italy, or in France.
Thank you very much, everyone. Have a good day or night, depending on where you are.
Bye, thank you.